Hi everyone, today we are going to study the traveling salesman problem in graph theory. So what does this traveling salesman problem say? Basically, the traveling salesman problem abides by a salesman and a set of cities. So we assume a situation wherein there is a salesman and he has to cover or he has to reach to a particular city beginning from his hometown. Now this salesman, as I said, has to visit every one of the cities starting from a certain one, which is obviously is his hometown or any certain city. So the salesman starts from a certain city, one particular city he starts from, and then he has to return to the same city after reaching its destination. So the salesman starts from a city, we call it his hometown, then travels across various cities and finally reaches its destination city. From that destination city, finally he comes back to his own city from where he started. So this is the situation we assume. Now the challenge of the problem is that the traveling salesman needs to minimize the total length of the trip. So he has to plan his travel in such a manner that for reaching his destination city, the cities that he chooses or the path that he chooses is the least or the smallest distance path. Just like when you have to go from one city to another city, right? So you start from your hometown, and then you want to reach a particular city. So you find out a path which is shortest among all other paths. To reach from, say for example, to reach from Delhi to Madhya Pradesh, there are more than three paths. So out of all those three paths, you will choose that path or those cities through which you cover the minimum distance in kilometers. So you will cover those cities via which you reach your destination in a shortest amount of time, covering less kilometers. So this is the task here, that the salesman starts from his hometown city and he has to reach a particular destination. Now from his hometown to that destination, there are several paths available. That means there are several cities that can be covered. But the salesman has to wisely choose that path which is the shortest. And when I say shortest, that means the minimum distance in kilometers. Now, if we suppose that there are cities called H1, H2 till Hn. So H1, H2 till Hn represents hypothetical cities, right? So every city will have a weight or cost associated with it, and that cost would be denoted by Cij. Now this denotes the cost of traveling from city Hi to city Hj. When I say Ci to Cj, that means from one particular city to another city. So that means starting from city I to city J, what is the cost of reaching from city I to city J? That is represented using Cij. So the traveling salesman problem is to find. So what is basically this problem all about? It is about finding a route starting and ending at H1 that will take in all cities with the minimum cost. So if you start from H1, that means you start from your hometown, then you have to start from H1 and then obviously you have to end also at H1, because wherever you reach, finally you have to come back to your hometown. Wherever, just like you go for vacations or you go for some official work, but finally you come back to your home. So you start from H1, in between you cover various cities, then you finally reach your destination, and then from that destination you finally return back to your home city, which is H1 here, which is represented by H1 here. So it will take in all cities with the minimum cost. Now from destination H1 to the, from the starting point H1 to the destination will come, various cities will come in between, or you will have multiple paths. You will have the option of multiple paths, but you have to choose that particular path which has the minimum cost. So cost, now you know how will be calculated. Cost Cij represents the cost from city I to city j. So now we will take an example. So with the help of an example, you can better understand how you will solve the traveling salesman problem. Now we consider a hypothetical situation, and we say there is a newspaper agent who daily drops a newspaper to the area assigned in such a manner that he has to cover all the houses in the respective area with minimum travel cost. So he has to distribute newspapers in a particular area. He starts from a particular location and he ends at a particular location, and from there he comes back to the location from where he started. He has to cover that entire area, or all those houses assigned to him in that area, with minimum travel cost. So basically the intention here is to minimize the traveling cost. So how would you do that? So the area assigned to the agent where he has to drop the newspaper is shown in figure below. So we have shown this area graphically. This is where we take the help of a graph. So this is a graph representing that area where H1, H2, H3, H4, H5, H6, H7 and H8 are those locations where he has to drop the newspapers in that particular area. If this graph is representing a particular area, so H1, H2, H3, H4, H5, H6, H7 and H8 are representing those locations. Or in other words, if this graph is representing a particular representing a particular geographical area which is covering various cities, then H1, H2, H3, H4, H5, H6, H7 and H8 represents individual cities. And if you now, one thing to notice here is that you can find some numbers assigned here on the edges. On the edges of the graph, you can see some numbers allocated to those edges. Now these numbers are known as the cost of traveling. These are known as the cost of the traveling from one city to another city, and these are also known as weight. So you can see this is the cost or weight assigned to the edges, and any such graph which has weight assigned to the edges is known as a weighted graph, right? So only in a weighted graph you can find the cost. So first of all, we are having a weighted graph, and these weights are representing what? These weights are representing the cost from traveling from one city to another. So for example, if you have to reach from city H1 to H2, the cost of traveling is 5, right? So there are if you have to travel from city H1 to H4, then the cost of reaching from H1 to H4, that is, which can be represented by C H1 H4, is 4. You can see that the cost of reaching from city H1 to H4 is 4. Now there are several options available to reach from H1 to H4. You can reach via H2. You can reach via H8. So like for example, if you reach via H2, then it will be from H1 to H2, then from H4. If you reach via H8, then it will be like H1, H8, H5 and H4. So there are several options available for reaching from one city to another city. But out of all those available options, you have to choose those options which have the minimum cost, right? The costs are already given to you, provided to you, and you have to just find out which path will have the minimum cost of reaching. So how do you find that minimum cost of reaching from one city to another? That we will see now. Now the solution is that. So I gave you the example of a newspaper agent. So the solution is that you have to find out the cost adjacency matrix of the graph G. How do you find the cost adjacency matrix of graph G? Like this. So you first put in all the cities in a matrix form, right? In a two-dimensional matrix form, you put in all the cities. So city H1 till H8. H1, H2, H3, H4, H5, H6, H7, H8 you have put horizontally, then vertically also you will put cities H1 to H8. Now you will find out the cost of reaching from one city to another with the help of this matrix. Now the cost is already provided to you, you do not have to do much. So this represents the cost of reaching from C. So cost of reaching from H1 to H1, Obviously, if you are at H1, then there will be no cost of reaching from H1 to H1. You are at that particular point only, so the cost will be 0. Then you can see that the cost of reaching from H1 to H2 is 5, which is written here. Then the cost of reaching from H1 to H3 is 0. Why 0? Because H1 is not directly connected to H3, right? The cost is written only for between those two cities which are directly connected. So H1 and H2 are directly connected, so the cost is 5. But H1 and H3 are not directly connected, so here you write the cost as 3. Then the cost from H1 to H4. You can see the cost of H1 to H4 is... The cost of H1 to H4 is 4 here. Then from H1 to H5, you can see the cost of H1 and H5 is 0 because H1 and H5 are also not directly connected. Then the cost of H1 to H6 is 4. From H1 to H6, the cost is 4. So that we have mentioned here. Then for cost from H1 to H7 is 0, that we have mentioned here. So basically you do not have to do anything. The cost is already provided to you from one city to another. You simply have to put it in this two-dimensional matrix. And you have to take care of the fact that for those cities which do not have a direct path, the cost will be 0. If you are at the same city where you have to reach, the cost will be 0. The cost from H1 to H1 will be 0. And in those cases where the cities are not directly connected like H1 and H3, the cost will be 0. For rest all the cities, you just have to put down the cost as it is, the way it is provided in the graph. Okay, now you can see out in the first row, we will start with the first row of this matrix. In the first row itself, this is the step 1, you can see the minimum or the least cost is 4, which is between cities H1 and H6, right? Which is between cities H1 and H6. So basically, you can see that the minimum cost is 4, so you mark it. That means H6 is the city which has the minimum cost from H1. Among all the cities or among all the locations, H6 is that location which has the minimum cost. So if you want to reach from one location to one location from location H1, the minimum cost location is H6, which is 4 here. So you have marked it. So you can clearly see H6 is marked because it is the minimum cost reachable from H1, and then you select minimum cost area reachable from H6. So H6 is the minimum cost reachable area from H1, you mark it. So the next step is that, okay, so this was step 1. Now after this you have found the minimum cost area reachable from H1, which is H6. Now you will find out the minimum cost area reachable from H6, which is your step 2. So you can clearly see out of all the costs here, the minimum cost area reachable from H7 is, from H6 is H7, which is 3. Now you would ask why 3, the 0 is minimum, but 0 cannot be considered because that is not the direct path available. So if there is no direct path, we cannot consider it, right? So 3 is the minimum. So from H6, which location has the minimum cost area? That is H7. If you start from H6, H7 is that a location which has the minimum cost of reaching from H6, which is 3. So you mark H7, right? After you mark H7, now the third step is to find the minimum cost area from H7. So again, the minimum cost area from H7 is H8, which is, and the cost of that area is 2. So that means to reach from H7 to the minimum cost area, H8 is that minimum cost area and the cost is 2. So now you have to find the minimum cost area from H8. So that is your step 4. So the minimum cost area from H8 is H6 and the cost is 4. Now you will ask, why not H7? It is less than 2. The cost is 2, but H7 has already been covered. So you will not cover that location again. You do not go back to that particular location from where you have moved forward. So that is why you will not consider that particular location again. So even though 2 is smaller than 4, but this cost is of location H7, which we have already covered. So next minimum cost after this is 4, and which is of which particular area? H6. So from H8 the minimum cost area is H6 and it is 4. Since H6 is the minimum cost area is H5, which is 4. Right, H6 cannot be considered because we have already covered it in step 2. So from H8 the minimum cost area is H5 and the cost is 4. So now we will find out the minimum cost area from H5. That is your step 5. H5, the minimum cost area from H5 is H2, which is 3. So if H2 is the minimum cost area from H5, now we have to find out the minimum cost area from H2. So which is your step 6. So the minimum cost area from H2 is H3 and the cost is 2. So now we will find out the minimum cost area from H3, which is your step 7. The minimum cost area from H3 is H4 and the cost is 1. Since H4 is the minimum cost area from H3, now we will find the minimum cost area for H4, which is your step 8. The minimum cost area from H4 is your the minimum cost area from H4 is the step 8. So the minimum cost area from H4 is your 6, which is your H1, because you have to reach back to that location. The intent is to reach back to that location from where you started. Now here H3 is also there and H1 is also there. H3 has already been covered, so we will not consider it. But then you will say H1 has also been covered, but we have to reach back to that location from where we started. So the minimum cost area from H4 is now 6, or rather we have to reach back to that location, so we will consider this cost. So in total 8 steps we covered the minimum cost area starting from H1 and then reached back to H1. So we started from location H1, we covered all the areas in this particular locality with the minimum cost, considering in mind that we cover them using the minimum cost, and then we reached back to H1. Now this can be shown in these simple steps. We started from H1. See, we started from H1 and the cost of traveling from H1. We started from H1. The cost of traveling from the minimum cost area from H1 was H6, right? And the cost of traveling from H1 to H6 was 4. Now since the minimum cost area from H1 was H6, so now we have to find the minimum cost area from H6. The minimum cost area from H6 is H7 and the cost of reaching from H6 to H7 is 3. Now since H7 is the minimum cost area from since H7 is the minimum cost area from H6, so we have to find the minimum cost area from H7. The minimum cost area from H7 is H8 and the cost of reaching from H7 to H8 is 2. Now since H8 is the minimum cost area from H7, so we have to now find out the minimum cost area from H8. The minimum cost area from H8 is H5 and the cost of reaching from H8 to H5 is 4. Since H5 is the minimum cost area from H8, so now we have to find the minimum cost area from H5. The minimum cost area from H5 is H2 and the cost of reaching from H5 to H2 is 3. Now H2 is the minimum cost area from H5, so now we have to find out the minimum cost area from H2. So the minimum cost area from H2 is H3 and the cost of reaching from H2 to H3 is 2. And since H3 is the minimum cost area from H2, so now we have to find the minimum cost area from H3. The minimum cost area from H3 is H4 and the cost is 1. And then finally H4 is the last location that we have covered. There is no other location that is left. So we will go back to the location from we started, that is H1, and the cost of reaching from H4 to H1 is 6, right? So this way we can find the minimum travel cost, that is 4 plus 3 plus 2 plus 4 plus 3 plus 2 plus 1 plus 6. So the minimum cost of traveling all the locations starting from location H1 and then reaching back to location H1 is 25. So whatever I have shown you in this two-dimensional matrix or this adjacency matrix is covered here in this. So this way, basically I have copied down the information from this adjacency matrix only. Starting from step 1 till the last step, that is step 8, if you copy down the cost of reaching from minimum cost of reaching from one location to another, this is how you will get it. And then you can sum up the cost of all these locations. So it gives you this sum 25. So you can say the minimum cost of traveling starting from location H1 and covering all the locations in that geographical area and then reaching back to the same location from where you started is 25. So this is the minimum cost for covering all the locations, and this is the traveling salesman problem.